Hey guys, so here is the jack screw for the connector that I'm working on at work, and we can't get these. We probably could buy the connector if we could come up with a good part number. I bought the mate for it, and that connector was like $1,200, and the only thing wrong with the one that's on the circuit board is one of these is missing and this one is damaged. As you can see, it's bent. So rather than spend the $1,200 on a new connector, I usually like to take scrap metal from work and see if I can't make it on my own time and just have some fun with it. So that's what this is I'm going to try to build one of these. And I'm going to build it out of these little standoffs that we have at work. They're stainless steel. They're just pretty much like the other thing, except the thread sizes are wrong, as you can see. I believe this is a 440, and this is a, I can't remember exactly what it was. Hold on a second, I'm going to go up to the drawing. So I drew it out, and so it's a 2.5 millimeter 0.45 pitch. And here's this. I just drew this on paint, and initially I only had the millimeters in it, and then I realized, wait a minute, my lathe is in inches, so I need to figure that out. So I used on my phone ConvertiPad, or I could have done other mathematical, but I like ConvertiPad. It's already on the phone, it's easy. So I drew this out. Now I know I can't draw threads worth a darn, but that's what I came up with. So here's the actual item here, all drawn up for this connector. And it's made out of 4 millimeter hex rod, which we don't have at work. So what I did is I grabbed some bigger hex rod. I think this is 1/4 inch hex rod or something like that. I don't remember. And I decided, well, I just need to mill that flat on all the sides. But how do I do that? And I figured out how thick it was in inches, and then I figured out how thick this was in inches, which was 0.156, and this one was 0.187. So basically I have to take what was it, 20 thousandths off of there? No, 30. I need to take 30 thousandths off. So if I take 30 and divide it by 2, that's 15 thousandths on each side. So if I stick it in a hex rod and then put it on the flat side like that and torque this down and super glue it in, thread it in there like I did, then I can go ahead and use my mill machine and lathe it off like I did on the bottom. I already laid off 15 thousandths off the bottom there. So, and what I did is I used my dial indicator and actually attached it to the outer shaft for the spindle. I know it's not the most accurate thing, but it's good enough for what I'm doing down here. So once I dial in what I need, and I do like 3 or 4 thousandths at a time until I get to the 15 thousandths, and between each one I go ahead and lock this right here, and then I can take this and I can push it aside. So this is the setup that I came up with. My 3-in-1 lathe, multi-machine from Harbor Freight. They don't sell this anymore, but let's see, Grizzly sells them and Bolton sells them. So if you're interested in one, depending on who you go to and the specials you get, this is the biggest one that Harbor Freight sold at the time. And let's see, that's there's the specs on it there. 17-inch lathe, swing over the bed, and 31.5 inches long from center to center down there. So it's pretty long, and it's big enough for what I need to do. It's actually bigger than what I need to do, but I enjoy it. It's been fun. I got mine 15 years ago, I guess, for like $800 or something, free shipping to the house at the time. I think they were on clearance. So now I don't think you can touch one of these for under $1,800. So, but I don't know. Anyways, getting off subject there. So anyways, what I did is I went ahead and chucked that up in this right here. that hex rod. I stuck it in the lathe. I turned it down. I made the round end on it. I think you can see it right there. Yeah, I made the round end with a lathe, and then I put my my whole get up here. I don't have any blocks, so I just put this extra cross light on it and my locking machine vise up there, precision vise, and I chuck it up like that, and then I just mill it off. And I go around all the sides, and then what I'll do is I'll take that back out and I'll stick it in the spindle, and I'll turn down the diameter for the thread to 2.5. Right here, I believe it's 2.5. And then for pretty cheap on eBay, I bought a split ring die and tap. So now I can have fun with it. Alright, I went ahead and set this up for my 0, so I'm going to make a 0 pass and make sure everything's fine there. If it's not, then I'll recalculate what I need to do here. So until then, I kind of need to take this off of here, and so it doesn't sit here and just vibrate. Here, let me show you what happens. So it's vibrating pretty good. Don't think I really want to do that to my dial indicator much more than that. So let me pull it off of there, which is just basically I got a magnetic base here. So let me get that. Alright, let's turn it on and see if it'll feed. So it looks like it was probably about 1/1000th off there. So I'm going to go ahead and lower this a little bit. Let me set the dial indicator back up on there again. You can see it's not moving over here, so it's not getting any vibration. But this up here is, the table is quite high, and it's extended quite far, so it's going to get some vibration, especially off of the head up here, which it has to go through here. So you're going to get a lot of vibration. So let me go ahead and set that back up and lower it. Alright, I've got my dial indicator back up there again. So let me go ahead and turn my knob here and bring the head down. So when I lock it down, I get a little bit of difference. So that's about 2/2000ths off. So I need to go up a couple thousandths. So I meant 5. Let me go back. There we go, 3/1000ths. Okay, and that's just from locking that in, it moves this back and forth. And since I'm taking the measurement while it's tight, I'm going to move it and then tighten it and then see what the measurement is. So that way there's as little variation in taking the measurements as possible. So let's go ahead and do the next cut. Well, let me get this off of here. Alright, I've taken my last cut, and I decided to just leave this on here so it's approximately the same position every time, and go ahead and just take my gauge, and I built this little knob here, or post on the back. And what I do is I stick that in here like this, if I can get it to go in. There we go. And then I tighten this thumb screw back here like this, and I move it around to where it needs to be based on my last reference. There we go. And for fine adjustments, I can use the knob up here for fine adjustments. And then what I'll do is I loosen this up and check it, and then I make my my movements here based on that. So, and then I tighten them down like I said before. So I found it was easier, rather than taking this off, to just go ahead and take the dial off the support here like that, and just set it over here on the lathe. So anyways, I've taken the last cut here, and now I need to go ahead and take it out and measure it and see how well I did on it. And if you remember, I'm I'm supposed to be at 157 here for a 4mm hex rod. So let's pull this off and see what I get. Okay, let's loosen this up. Come off of there. Stick this in there. Spread it a little bit. And let's get this out. Oh, and each time I put this in here, make sure it's in the right spot. And I bring this over and I touch off, and then I make sure that this is up against the bit physically. Then I tighten it down and make sure that my zero is accurate for each cut that I made, and I had to make 6 of them. So let's measure this now and see what we get. Right, on that side I got 158, which my target was 157, and I got 156 on that, maybe just a little bit under. And that one, it's about if I come over here, it's about 156.5. So one of them was a little high, and for you guys that know, that's about the thickness of a piece of paper. So I think that's going to work just fine. So now I need to take this off of here. I need to take this off, turn it around, stick it in the lathe over here, and turn it down to my 2.5 here. And then I'll use my my die wherever I put it. I drop. Oh, here it is. I'll take my die and go ahead and thread it. Anyways, let's go ahead and do that. All right, let's get this out of here. I already loosened it up. This is actually not supposed to have a hole in it, but it's not going to matter in functionality. Cut some of this off all the way around, 6 cuts, a little extra deep into this hex thing I was using as a holder, because I wanted to make sure that I got all the way around on this thing. I didn't want to leave like a raised area. So I did. So the next thing, like I said, I need to do is turn this down to a 2.5mm. and then tap it to 0.45 millimeter thread pitch, which is like I showed you before, the die. So let's go ahead and get this chucked up in the lathe and turn it down. Okay guys, I've done my second one. Remember, I have to build 2 of these things right here. Here's the original one. I have to build 2 of those. So I've parted it off. Now I need to make this little step right here, and that is 69 thousandths. So what I have to do is move the tool bit that direction. Well, I'm on a slide here, and I want to show you a little trick on how I do it. And you have one of these, you can go ahead and pull this out 69 thousandths. I usually use my dial indicator, and I set it in here like this, and I tighten it up. Make sure you lock this, by the way, and I tighten it up until this just barely fits in there, and no slide back and forth. So obviously I got a little bit more to go. Anyways, once I get that done, then I go ahead and I unlock my carriage slide. Then I take my cross slide and I make sure it's clearing the item I want to work on. And then I take the carriage, move the carriage over so that it just touches the work I'm working on, like that. Then I back out my cross slide here, so it's no longer touching it. Now I can move this in the 69 thousandths, which I had preset. I can go ahead and start this up until I see it start to cut after I engage it. But before I do that, I really need to know how far this has to go in. From peak to peak, it's 5.37 millimeters, or 211 thousandths. Because remember, it's a hex rod, and the hex I'm looking at, I have to drill a hole in the flat side. So I showed the drawing this way, which is peak to peak, which is the this measurement here. So I have to go down to this measurement, which is 114 thousandths. So basically I have to subtract this from that, and that tells me how far I have to trim off, and then whatever that is, that tells me how far I have to move the cross slide that way. And I have to divide that number by 2, because whatever you're taking off of this side is also off of that side, so the measurement will be double. And when I was first learning machining and playing around with my lathe and learning, that was the one thing that kind of took me a few tries to learn. So anyways, let's go ahead and do the math on that, and then I'll write it down, then we'll divide it by 2. And then after I set this up in here so it's just touching on the part I want to cut, then I can go back over here, set this to 0. Of course it would be this direction. I can set that to 0, and then I know how far I have to go this way for 50% of my distance. That will give me my little step that I need right there. Okay, so there's the math. I did it. It's 97 thousandths. So we divide that by 2, and that gives us basically 48 thousandths. And I'm going to go ahead and round down. I'm not really going to worry about a half thousandth or whatever. Just not going to worry about it. Alright, so now what we have to do is we have to fire this up. I don't know if you'll be able to hear me, but I'll try. Alright. And we move this in till it just starts to touch. Yeah, I barely hear it right there. So now what we do is we take this and we 0 this. And I'm going to say I've already added 1,000ths because it's touching. So now we know how far this has to go in. So let's just slowly take it in there. I'm going to do 5 thousandths. Now remember, I'd previously set this for 69 thousandths. Guess what? Now I can use this, since it's bottom out, and unscrew this out, and it'll clean off the backside for me automatically as I back it out. And since I haven't moved my cross slide, I can take it back in, bottom back out, and I'm right at my 69 thousandths depth again. Now I can take this another 5 thousandths and then back this out again. Put it back in, bottom it back out. Take another 5 thousandths. There we go, I finished my cut, but I actually made a mistake and I caught it in time. And that is, when I was showing you guys how to do this, I'd already done it and I forgot, so I actually doubled the distance that it ended up going back in. But I started cutting and I said, that doesn't look right. So I went back and rechecked my measurements, and sure enough, I did just exactly what I told you. But I hadn't cut down far enough below the 4mm diameter that I'm going to be doing, or the 157. So I got really blessed on that one there. I could have taken this down all the way and then I would have gone too far, and that wouldn't have been good. I would have had to start this project over. But fortunately, I only went down a few thousandths before I caught it and said, that's not right. So now what I'm going to do is I'm going to go ahead and turn this shaft down. 2.5mm, I think it was. Yeah, 2.5mm. So I'm going to go ahead and chuck that up and turn that down to 2.5mm. So let's go ahead and chuck it up. Alright, I've got it chucked up in there, and you'll notice I have just a little bit of clearance. And when I do this, I'll be moving this back and forth. I'll lock the carriage, and I'll only move this cross slide here in and out like I did before to make sure that I don't run into the chuck when I'm turning it. And you know, anytime you do this, always, you know, hand turn your chuck. Make sure you're not bumping or rubbing into it. I'll have to go ahead and measure those threads right there. Alright, I've used my dial calipers here to measure the diameter of the threads over here. And they're 0.18, so 118 thousandths. So So if I take 118 thousandths and I subtract the diameter of the threads I'm going to need in inches, it's 0.98, I get 20 thousandths left over. So that means I have to reduce that diameter by 20 thousandths. So let's go ahead and take the tool and bump it up to the threads here, and then we'll go ahead and set this at 0, and then we'll cut 10 thousandths off, because whenever you cut here, that's double, because you're cutting it off double, both sides. So let's go ahead and do that. Okay, I've just touched off right there. So now I need to set this to 0. And I need to cut 10 thousandths off. So let's go ahead and, but I'm going to do it really slow because that thread is really fine and it's sticking out. And hopefully I'll have enough on there that I can actually tap. Alright. There it is. Like I might have a little bit of the old thread left over, but the tap will take care of that. Remember, this is just some scrap I have from work, and this is the closest I could get. So let's go ahead and measure that now that I've taken 20 thousandths off. Hopefully I'm in the ballpark. Alright, that's what I got right there. It was a little under 98. I'll take that. So now all I have to do is tap that with the die down here. So let's go ahead and do that. Okay, here we go. I went ahead, since these threads are so short and it's such a small thread thing, I went ahead and I'm just going to do this by hand. Here we go. Obviously I'm a little bit off there, but this is the connector that I'm putting this on already has a bunch of slop in it, designed already, so this isn't going to be critical. Otherwise I'd be a little more worried about it. Okay, I think that's it. We're bottomed out. So let's take this back off, see how it looks. Let me get that out of there. Okay, there it is. It's tapped and everything. You can see the threads. I don't know how close I can get with this. There we go. And this one over here is the original. Let me get it out of there for you. There we go. Now that one on the top there is the original. The one on the bottom is the one I just made. I probably could take a file to it, stick it in the lathe and take a file to it and kind of round it off like that one, put a little point on it, and maybe even dress the back up just slightly. But overall it's pretty good. This little piece right here was one of the pieces I cut off of here before I shrunk them down, and I tapped it to the 2.5 0.4 millimeter thread, and I put it in there to see how it fit, and it was perfect, just like the original was. So it looks like now all I have to do is do some little dress up work, and I've got to cut that little hole in there in this one. Well, there it is. I drilled the hole in it. The original one is on the right. It's a little bit longer, and the hole is a little bit more towards the front, but other than that, they're pretty much the same thing. So tomorrow I get to check it out and see how it does. Well, I brought them to work and I'm getting ready to install them, and they basically go in this way with the holes up, and then you put the screw there and you put a nut on the bottom, kind of like this one here. I don't know if you can see it. There you go. And then the nut goes on the bottom right there. Now, interesting thing, this nut actually has a small recessed area. I think these ones are supposed to have it too, but I don't have any nuts like that. So I'll just put some Loctite on them and stick them in there. And this connector right here is the one that goes on it. And it actually goes on this way. Right there, you put that little guide pin there and it goes there. And what these are for right here is as the wires go in, you can bundle them and put zip tie or spot tie around them, and it'll hold the wires steady because, you know, they're kind of fragile. 300 and some pins, I think it was, going in and out like this. You're gonna want something to hold your wires. You don't want to be pulling on your wires, especially these ones over here will tend to break. I know that from experience. So, well, anyways, let me get these installed here. Yeah, there it is. It's kind of hard to do it on the camera. Boom. All right. Now I'll have to actually use two hands because I got to stand this board up and do it. Well, I couldn't find any Loctite at work, so I'll just use a little bit of super glue, and so I'll just grab just a little tiny dot of super glue there. Doesn't take much. Now you can actually put just a little bit of soldering iron heat on this, and the super glue will release. So that's good to know if you guys didn't know that. So let me go ahead and get that on there. I already got my screw in. See, it's down in there, and screw is just the perfect length. I don't know exactly what size that screw is. I think it was a 0, but I don't know the pitch. I'm sure it was pretty fine, like 72 or something like that. Okay, it's installed right there. All I gotta do is go do the other one on the other side down here. So let me go get that. Alright, got that screwed down. So let's set it down over here. And just as a little added measure, man, I can't get this thing to focus today. We'll put just a little extra right here. And it's not a lot, just a little bit. You can also use a little bit of dab of epoxy on top of this. Epoxy releases with heat too, which is really nice. Or if you let alcohol soak on it, it'll start to release as well. Some people don't know that, but if you're one of those people, now you know. Alright, so that should take about an hour to cure and dry. So let's see if our connector will actually connect up on it now. See if I can get that in there one-handed. Nope, not one-handed. Alright, got it here. So let's use our screwdriver and see if we can't jack screw that in. See if it'll work. Alright. Here we go. I didn't be able to use my fingers. Well, there you go. It snugged right down. It was a snug fit, but it wasn't a real tight fit. So I had this off earlier, so I need to tighten that back down. Glad I saw that. Okay, so it looks like we can call that a wrap. That's a nice little job there done. So that just saved our customer about $2,200 just by me building those two little things, so I didn't have to buy this whole connector back here. So anyways, God bless you all. Thanks for watching. If you learned something or liked the video or whatever, just give me a thumbs up. If not, well, you know, whatever you got to do, comment. So God bless you all. Take it easy and keep none you out. Bye.